Every physical system degrades. In human biology, aging is the continuous, inevitable fracturing of complex microscopic structures under the pressure of time. Modern research describes aging as a highly interdependent network of cascading biological errors. In 2013, a scientific consensus first defined this network using 9 distinct biological hallmarks, specific categories of cellular failure that happen as we age. In 2023, researchers expanded this framework to 12 hallmarks, incorporating new evidence on how our cells communicate and recycle waste. These 12 hallmarks are organized into 3 hierarchical layers based on biological causality: primary, antagonistic, and integrative. This 12-part hierarchy provides a roadmap for shifting from symptom-based treatments towards interventions that target the underlying biological structure of aging. To understand how these interventions work, we must first trace the biological cascade from its molecular root causes up to systemic clinical decline. Viewing aging as an interconnected topology suggests that therapeutic approaches focusing on a single pathway may be limited by the rest of the network's behavior. The aging cascade originates at the deepest level of our biology, the nucleus and the genome. This core represents the primary hallmarks, the foundation of the aging network. These represent the initial, unavoidable accumulation of damage that occurs simply through the thermodynamic cost of a cell existing and operating over time. This root damage consists of 4 mechanisms: genomic instability, telomere attrition, epigenetic alterations, and the loss of proteostasis. Proteostasis is the cell's internal quality control system for building and folding proteins. Across a human lifespan, these primary errors accumulate silently. They mount for decades before any external signs of aging become visible. While this primary damage is an inevitable part of biological existence, the speed of aging is dictated by how the body reacts to these errors. As the primary damage builds, the biological system attempts to defend itself. This brings us to the middle layer of the network, the antagonistic hallmarks. These 3 mechanisms are deregulated nutrient sensing, mitochondrial dysfunction, and cellular senescence. These mechanisms evolved as adaptive, protective responses triggered by the primary damage occurring in the core. Consider cellular senescence. When a single cell detects significant DNA damage, it can intentionally halt its own division. This freezing prevents the damaged cell from duplicating and potentially becoming cancerous. While these defenses are protective in the short term, they reach a temporal inflection point when they are chronically activated for decades without relief. Chronic activation causes these defenses to dysregulate. Over time, the adaptive response becomes a primary driver of aging pathology itself. Once these compensatory mechanisms fail, they accelerate the transition from localized cellular stress to systemic decay. At this stage, we zoom out from individual cells to the macro-level environment of tissues and organs. This is the outermost layer of the network, the integrative hallmarks. These are the 5 end-stage failure points: stem cell exhaustion, altered intercellular communication, and chronic inflammation. Next is dysbiosis, an imbalance in the gut microbiome, and impaired autophagy, where cells fail to recycle damaged components. This accumulation of root damage and fallout from dysregulated responses finally overwhelm the body's repair capacity. The result is a loss of tissue homeostasis, where the structural integrity of the body begins to unravel. These 5 outer markers result in the clinical realities of aging: physical frailty, cognitive decline, and increased susceptibility to disease. This creates a feedback loop. Systemic failure in the outer ring feeds back into the center, further accelerating the primary genomic damage. This is the fully activated state of the 12-part aging topology. Diagnosed clinical disease is the final, visible manifestation of this cascading network failure. This network structure poses a challenge for clinical practice. How do you effectively intervene in a system that is failing across 12 interconnected points? Traditional medicine often targets a single node in isolation, an approach known as the single target fallacy. Because the aging hallmarks are interdependent, the broader network often routes around a localized fix. If you clear out senescent cells, but ignore genomic instability and inflammation, the cascade continues through the remaining pathways. Systems-based models, like PrimeSpan, address this by applying simultaneous pressure across multiple nodes of the network. By using the 12 hallmark framework, we can map lifestyle interventions directly to the biological layers they influence. Modern health span programs utilize 5 primary levers: nutrition, exercise, sleep, stress management, and gut health. Precise nutrition protocols are designed to modulate nutrient sensing, dampen inflammation, and support mitochondrial health. Strategic exercise is used to regulate stem cell function and build systemic metabolic resilience. Sleep architecture is linked to the repair mechanisms of autophagy and proteostasis, while gut protocols resolve dysbiosis and stabilize immune signaling. Because these systems are connected, small improvements across multiple nodes create compounding benefits that an isolated treatment cannot match. This strategy aims to stabilize the entire biological topology, restoring rhythmic harmony to the system. Engineering systemic resilience across all 12 hallmarks provides a scientifically rigorous path to extending human health span.